In this example that I'm considering, matters are a little bit more complicated because the region that is formed by these three curves will be a little bit confusing because you can't trap the region between two vertical lines or between two horizontal lines where intersections do not happen. In fact, there are intersections in between, therefore it can neither be Rx nor Ry. But unless we see the graphical representation, you cannot analyze the region. Now let us begin with the first equation given to you. Xy is equal to 4. I hope you have decent knowledge of how a rectangular hyperbola looks like. So that's a rectangular hyperbola. We'll try to draw the figure also. No problem with this line. It is a straight line through origin. X is equal to constant is a line parallel to y-axis. So let's put it on graph. Xy is equal to 4 will have two branches. These are the two branches of the hyperbola, symmetric about the origin, which means the two branches are in the first and third quadrants. X and y axis are asymptotes. This is intersected by the line y is equal to x. So I'll use a dotted line now. This is the line y is equal to x. The immediate thing you should do is to locate the point of intersection of the hyperbola and the straight line. So you solve xy is equal to 4 and y is equal to x. When you insert y is equal to x, you get x square is equal to 4, giving you two solutions, x is equal to plus or minus 2. For x is equal to plus or minus 2, y will also be plus or minus 2, which means there are two intersection points, 2, 2 and minus 2, minus 2. So the rectangular hyperbola and the straight line are intersecting at 2 points. Now comes the complication. X is equal to 4. X is equal to 4 is a straight line parallel to the y-axis. Clearly to the right of this intersection point, because here x is equal to 2 is the coordinate, whereas this is x is equal to 4. Therefore, this vertical line cannot pass through this intersection point with this. Now, I will just add one more equation here. Y is equal to 0. So y is equal to 0 will be this line. So now you can see a region that is formed between the hyperbola, the line x is equal to 4, the straight line y is equal to x, and the x-axis. This is the region. So this region is pretty complicated. So you cannot trap it between vertical lines. Actually, you can see the vertical lines, but there is an intersection there, which means that it is not an Rx region. If you try to draw horizontal lines, let us say you draw a horizontal line there, and this is the other horizontal line, then you will find there is one intersection point there in the corner. Even that is not allowed. So under Ry, this intersection is not allowed. In Rx, this intersection is not allowed. Which means that this region R is neither Rx nor. So when you face this situation in a double integration context, you'll have to go for what is known as a region splitting. Region splitting. Let me explain that. Suppose you break this region into two pieces. I will draw one horizontal line here. Call this region as A. Call that region as B. Now you can see that A is an Rx region. B will be another Rx region. So let me explain A as an Rx region. An Rx region is trapped between vertical lines. So what's the equation of this line? That has to be x is equal to 0. What's the equation of this line? That has to be x is equal to 2 because it passes through this point. So x is equal to 0 to x is equal to 2, semicolon. Don't look at B, only look at A. X is equal to 0 to 2. This is the lower boundary, that is y is equal to 0. And this is the upper boundary. And what's the equation of that? Y is equal to x. That describes the region A. Then how do we describe region B? B is a continuation of A. So again, it can be observed between two vertical lines. What are x limits? X is equal to 2 to x is equal to 4, semicolon. This is the lower boundary, so it continues to be y is equal to 0. And this is the upper boundary. Be careful, it has to come from the hyperbola equation xy is equal to 4, which implies you must write y is equal to 4 by x. Y is equal to 4 by x. So this is the concept behind region splitting. Of course, when you evaluate the double integral, it is double integration over A plus double integration over B. And the limits are what you see, 0 to 2, 0 to x, some function, divide x, plus 2 to 4, 0 to 4 upon x, f of xy, divided x. So this completes three contrasting problems. The first problem where the region can be expressed as both Rx and Ry. 2. The second problem where we could only express as an Ry region. And the third one as a sum of two Rx regions. So one must be prepared to work in any situation. Of course, the next challenge is integration challenge. So that we'll be taking up in the next class. I hope you got it clearly. Dear friends, you have heard so far, I've considered varieties of regions. A region which was a simple Rx region, and then I've explained in the last problem how an Ry region is formed, which is not classified as Rx. But suppose I take a problem like this. We have some function xy to be double integrated, and the region enclosed by these curves y is equal to x, y is equal to 2x, and x plus y is equal to 2. And because they're all degree 1 equations, they all must be linear. So they all represent straight lines. The first two equations represent straight lines that pass through the origin because you don't have the constant term. Whereas the third equation is a straight line that does not pass through the origin but has equal intercepts on the x-axis and y-axis. So let us first draw a rough sketch of this region. So we'll begin with y is equal to x. I'll use a dotted line for y is equal to x. I'll write that equation here. Then y is equal to 2x has got a slope 2 which is more than this slope. So we know that the slope is 1 means the angle is 45 degrees. When the slope is more than 1, the angle has to be more than 45 degrees. And if you actually estimate, you will find this particular line inclined to the x-axis at an angle theta is equal to tan inverse 2, which you can estimate to be approximately 63.4 degrees. So that's tilted more towards the y-axis. So let me show that like this. So this is the y is equal to 2x line. Now comes the third line, which is having equal intercepts on the x and y axis of 2 units. So let me draw that line here. And it is the region between y is equal to x, y is equal to 2x, and x plus y is equal to 2. So this is x plus y is equal to 2. So this is the region of integration. So that's the region. So you can see it's a triangular region, but the triangle in a nasty orientation. So that itself is enough to sort of sense that things are going to be complicated. So let me enlarge this figure for you. I will not show the other details. So I have this, I've got this, and I've got this. Now, let us see. Does 1 comma 1 satisfy y is equal to x and x plus y is equal to 2? Answer is yes. So I got this 1 comma 1 by solving these two equations. Then this point should be the point of intersection of y is equal to 2x and x plus y is equal to 2. And let us see if it is 4 by 3 comma 2 by 3. Does 4 by 3, 2 by 3 satisfy this equation or the other way around? So let us make this 2 by 3 and this 4 by 3. I think y is equal to 2x will satisfy this because 4 by 3 is 2 times by 3. And then this is where we are. Anyway, the way I got this 1 comma 1 and 2 by 3 comma 4 by 3 is to solve the corresponding equations, right? So this equation and this equation solve and get it. This equation and this equation solve and get this. Okay. Now, if you look at this region, it is neither Rx nor it's neither Rx nor R. Why? Because if you think it's Rx, then I should be having the region trapped between these two vertical lines. If that is the case, so this line and this line does enclose this region, but between them there is one prohibited intersection there that is not allowed by the definition of Rx. Between the extreme vertical lines, there must be no intersections, which means that it's not Rx. Is it Ry? Let us see the same region between horizontal lines drawn at the extreme points. The story is the same. Between these two horizontals, there must be no intersection, but there is, which means that it is not even ry. So, what do? When the region is neither Rx nor Ry, we have no other option but to segment the region. So should we segment into Rx regions or Ry regions? That choice is left with us only. So we can choose any one of them. But there is a thumb rule. Don't split the region into too many parts because each part consumes integration. So therefore it takes away all the time in the integration. So split into two because that's the minimum number of segments that are formed. But if some region has to be broken into 3, 4, etc., better to avoid. So I will split it into two regions and let me choose to explain the splitting as two Ry regions. In which case, I will draw the horizontal line there. There's a horizontal line here. This is the point where I split the region into two parts. And I'll call this lower block as A and this upper block is B. So let me sort of shade this differently. I'll use some vertical lines for shading this. And let me say I'm using horizontal bars, horizontal lines to represent. So you can see that this lower region A and that upper region B can be easily described as Ry regions. So let us focus on A. A is an Ry region. What are the y limits? Y is equal to 0 to y is equal to 1. Between these two parallels, y is equal to 0 to y is equal to 1, semicolon. Now comes the x limits. X is equal to this line is this line. So you write x as a function of y, x is equal to y by 2. And then this line is the right boundary. So this will come from this one. So therefore, x is equal to, so I'll write x varies from y by 2 to x is equal to y. Then B is the continuation of A starting from here going up to that point. The equation of this horizontal line is y is equal to 4 by 3. So y is equal to 1 to y is equal to 4 by 3. Semicolon. Now comes x. This is the left boundary, which is the same as the left boundary of the region A. So that will continue to be x is equal to y by 2. But this right boundary comes from this one, whose equation is x plus y is equal to 2. Therefore, x is equal to 2 minus 1. So x has a lower limit y by 2 and an upper limit 2 minus 1. X is equal to y by 2. To x is equal to 2 minus 1. So your requirement is to double integrate over the entire region, but we have broken it into two parts. I will call them I1 and I2. I will separately evaluate I1 and I2. Then, after evaluating, I'll put it back into this equation to get the final one. What is I1? Integral y is equal to 0 to 1. X is equal to y by 2 to x is equal to y. The function is xy. The order is dx dy. And then I have I2, which is integral y is equal to 1 to 4 by 3, x is equal to y by 2, to x is equal to 2 minus y, xy dx. So these two integrations, I leave it as an exercise to you so that you will be able to get sufficient practice. As I told you, the idea of this present segment of the lectures is to understand how to analyze an Rx region or an Ry region, then fix limits logically the correct way, and then fix the limits of double integration and then evaluate. You can check if these outputs you are getting. In the first case, check whether the output is 3 upon 32 and check whether the second one is 11 upon 162. Then from equation 1, I is equal to 3 upon 32 plus 11 upon 162, which should settle to 419 by 259. So this is a small exercise. I'm just leaving it to you. You can try that. You will find that all these problems very soon will be available in the PDF form so that the detailed solutions can also be referred to. But the lectures that I'm presently delivering are those which are highly concept based, because it is this that will ultimately matter. So learn the correct way of understanding regions, fixing limits. Then evaluation, of course, is a crucial step, but that you can develop step by step. So the next lecture will be a very important aspect of double integration, of course, in the Cartesian framework only, and that will be how to change the order of integration and why is a change of order integration necessary. So that will be one of the exciting lectures. Let's wait for that.